Okay, this is a quick video just for a friend who asked a question, and before I begin, I just want to explain one thing, because this is the sixth root of something, and in this problem it's the eighth root of something. I just want you to be clear on this. If I had the square root of 4, that's the same thing as the square root of 2 times 2. Square means I need 2 of the same number, right? That gets crossed out, and it comes out as a 2, so my final answer would be 2. And that's right, the square root of 4, 2 times 2 is 4, is 2, right? So whenever I have 2's, like let's do this, the square root of 32, that is the same as 2 times 16, 2 times 8, 2 times 4, 2 times 2, right? So boom, 2, 3, 4, 5 2's. So that's the same as the square root of 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. That's it, right? Right? So I can take 2, any 2 of the same number can come out as 1 of those. Another 2 of those same numbers can come out as another 1, and you multiply them together. This is still left over, so it would be 2 times 2, 4, that's on the outside, square root of 2 on the inside, right? So now, just so you know that, so like if I gave you, what is the sixth root of, think about this, sixth root of x to the sixth? Well, it's going to be x, because that's the same as saying I need 6 of the same thing, but I have 6 of these x's, right? 1, 2, 3, 4, 5, 6. So every time I have 6 of them, it can come out as 1x. So my final answer would be x for this. Okay, so we're going to use that principle in these problems. So I hope that makes sense. This is kind of a quick thing, but hopefully it's useful. So I see immediately that I'm going to be able to take the square root of g to the 6 is just going to be g. But I'm not going to deal with it yet. I'm going to wait, because I want to look at the h's. I want to get the h's on the same level, either both on the denominator or both in the numerator, or both in the denominator. Now, if this is h to the positive 1, if I bring this h downstairs, it would then be h to the negative 1, right? Whenever you cross a fraction line, the exponent changes sign. So it went from a positive 1 to a negative 1. So whenever you have same bases with exponents and you're multiplying them, you simply add the exponents. So h to the 7 times h to the negative 1 is h to the 7 minus 1, or h to the 6. Oh my gosh. So that is saying then we want the sixth root of g to the 6 over h to the 6. Oh, well that's easy, because it's g, whatever, g times g times g times g times g times g, that's 6 g's. That's just going to come out as a g. That'll come out of this sixth root sign. And the h, there's 6 of those too, that's just going to come out. So that is your answer right there, g over h. I hope that made sense. All right, so we're going to use some of the same principles on number 2, on this one. It's the eighth root of n to the 18th, p to the 7th, over n squared, p to the negative 1. So if I bring, I'll write it out so you can see what I'm doing. If I write n to the 18th, and I bring this, the n squared, upstairs, because I have n's upstairs and downstairs. I do not want that. I want them either both upstairs or both downstairs. Since I want them positive, I don't want to bring the n to the 18 downstairs, because then it would be n squared times n to the negative 18. I don't want to deal with that. I'm going to bring the smaller exponent across the fraction line. So it's n to the 18 times n to the negative 2, right? I still have the p to the 7, right? And I am now, I notice this too, if I have p's upstairs and downstairs, I want to move the smaller p, the p that has the smaller exponent, I'm gonna move that upstairs, and now it's gonna be a p to the positive 1 as soon as I move it upstairs. So I'm gonna put that, p to the positive 1. Look at that, I no longer have a denominator. I don't have to worry about it anymore. There is technically a 1 under here, but the 8th root of 1 is 1. 1 times 1 times 1 times 1 times 1 times 1 times 1 equals 1, right? So, so I can, so really, all I have to worry about is the numerator, because the denominator is just going to be 1, so I don't need the denominator anymore. So our final answer, well, we've got the 8th root of n to the 18 minus 2, which is 16, right? And then p to the 7 plus 1, which is 8. Oh my gosh. So this is n to the 16th. I'm assuming you know this, but I'll do it anyway. N to the 16th is the same as n to the 8th times n to the 8th, right? N to the 8th times n to the 8th is n to the 8 plus 8, which is n to the 16th. Oh, that's interesting. Times p to the 8th. Okay, so the 8th root of n to the 8th is n. The 8th root of n to the n is another n, right? The 8th root of p to the 8th is p. So those all just came out of the 8th root sign, right? So my final answer is going to do, I'm going to combine these. N times n is n squared p. Okay? So that would be my final answer, right there. That would be the simplest form, just like g over h was the simplest form there. So I hope that was useful. Just a kind of a quick thing. I'm kind of racing, so I'm kind of covering it up when I'm walking in front of it. But hopefully that's useful. Okay, thanks. Bye.